focus on is you. And tell me a little bit about your background. How did you come with the company? Just to make it brief.
Okay. Well, I started low in the air. I went as high as I could.
Okay.
Started with aero modeling, building aero models. Went up a bit to build. I was in 9 or 10 years in the UAV business in Israel.
Oh, really?
That wasn't high enough, so I went into the satellite industry. I worked for 10 years at IAI, Israel Aerospace Industries. I worked on big communication satellites, the Amos series, and also with small satellites. I did a bit of both. And then 2 years ago, me and my partner opened the company. I left the day job and became full-time entrepreneurs.
Oh, okay. Well, this is very similar to Silicon Valley, where I'm from, so I really applaud you for staying focused. Yeah, it's very important. The global space industry was estimated to be $323 billion in 2015. And the latest year for which data is available, according to the Space Foundation, they're looking at commercial space business about 76% of the industry. And also we see that there's a lot of nano satellites, Space Foundation is doing this. Also Russia recently launched, of course India, but they recently launched about 37 satellites in a single mission.
It was 104.
I'm sorry?
It was 104.
Oh, okay.
I had 2 on there.
Oh, good.
From old projects.
Thank you for correction. Also, NASA carried about 29 satellites in 2013. And so I'm just kind of wondering, you're estimating 40 to 100 nanosats per launch. Is this trend for massive nanosatellites a real sign, a trend for sending more small satellites instead of fewer?
Well, we're talking about our system. One of the things our system does, the antenna, the communication system, it turns a very small satellite into a mean machine of communication. So, in my view, because of technologies like ours, the geostationary and communication satellites become smaller. The small satellites are maybe going to get bigger. They're going to become communication satellites. And because of capabilities of microelectronics and making things smaller, because of our technology, which is something that's packed when it's launched and deploys in space, so all of this compactness enables small satellites to be much more powerful. By the way, the same technology we're using for the antenna can also be used for solar panels. So if we need much bigger solar panels on such a small satellite, the same kind of shape memory materials can be also used for that. So in my view, yes, there will be more small satellites going up than large satellites, and the small satellites will be able to get close to the capabilities of the larger ones. And of course, the launches hopefully will be more opportunities with all the new small satellite launch providers. If they'll be operative in the next year or two, we'll have more access to space. One of the main issues today is access to space for the small satellites. It's difficult to get to launch, some of them are delayed, so that has to improve. But small companies like ourselves who are working on new rockets for small satellites will be very helpful.
So are you actually looking at SpaceX to do some launches for you?
Yes, we are.
That's already in the
actual satellite. And then when he gets up into space, he just pops out like a jack in the box. And eventually writes itself.
Well, okay, thank you.
Okay, I've broken it.
I think the next question really was, why is this such a remarkable feat? I think you answered that question because if you have one launch and you can put more satellites on it. One thing I was going to ask you, is there a proportional relationship between size of the satellite and the size of the solar panels?
Yes. Well, first of all, one more remark on what you said before. Some of the interested customers are interested in our product because they want a smaller volume satellite in launch, because they want to put a few satellites in the same launch. I'm not talking about CubeSats, I'm talking about much bigger satellites, but they want to launch a few together. And that's why, even if they want a big antenna from us, 2.5 meters or 5 meter antenna, if it's so compact with launch, it means the whole satellite is smaller, and therefore they can have more satellites in one launch. Regarding the question about solar panels, obviously it depends on the size of the satellite and also the power you have to transmit. If you have to transmit more power, it means the satellite has to generate more power. So the solar panels will be bigger. And if you're transmitting with a high power, you have to dissipate that heat somehow. And for that you usually need a bigger satellite. You need bigger properties in order to dissipate that heat. You have to bigger, I call it real estate. You have to have more panels on the satellite so you can dissipate that heat because you're transmitting at such a high power. So on one hand, you need big solar panels to make the power. On the other hand, you need a bit of a bigger real estate to dissipate that. So there's definitely a correlation.
Yeah. Well, thank you for that point. Why is low mass expandable antenna systems going to be the game changer?
Okay, so low mass and volume is one aspect of what we're doing. Obviously, low mass and volume is benefit for the launch, obviously. So we have a lower mass at launch. We also have a lower volume, so as I said before, if you have more satellites in the same launch, that's already saving you money, and less mass is also saving you money. So there's a big save of money on the launch, and that's good. But obviously it's not the only thing we're offering. We're offering the fact that you can store a large dish in a small volume. So, 5-meter antennas today do not fit. If they're rigid, they're not fit in a launcher. They don't fit in a canopy. So you have to have a folded 5-meter antenna. So if you can have it in a very small volume, you can have a 3, 4, 5, 7-meter antenna and then launch it easily. So that's the benefit of the small volume. And mass is what I said. Of course, we have all the other capabilities. We have our sub-reflector. We can do any corrections in space. So we don't have to have the most accurate antenna in the world because we can fix it in space. The adaptive flexo sub. And of course, the pattern shaping. That's one of the main IP of the company. Is the fact that we can control the footprint, change the shape of where you're covering on Earth. So it's good for GEO. It's also good for LEO because you're going over a different place all the time. One antenna does not fit all. And when you're going over different places, you can change the shape and concentrate your energy over the different countries you're going over. So that's our main goal. It's not only massive volume.
Right. I thought that was really, I had no idea that you can actually adjust in space, so I think that's a really important point from the engineering side of it. And what do you think is the longevity of the systems once you launch? Is it after 2 years, 3 years?
We're designing the system to withstand the space environment and lifetime of the satellite. Obviously, we can't be the system that derives the lifetime of the satellite. Otherwise, that would be silly. So we're choosing components that are compatible to really. So now we're doing a LEO satellite, so it's compatible for 5 to 7 years, no problem. Obviously, there'll be a bit more NLA to put in for a GEO satellite, just for radiation, for example, and electronics. But it's just a choice of components. So that's electronics. But all the other materials, composite materials, the membrane material, it's all space qualified materials that are used in satellites, and there's no problem for lifetime, even GEO. It's all space qualified materials.
Great, thank you. I just have a couple more questions. How do you size up the service companies who are aiming to provide low-cost images and communications with the full coverage of the Earth? Can you give at least a couple examples?
So we're doing a communication system, which is more for applications of communications. However, as you said, there are many satellites that are not communication satellites. They have different pillars: images, sensors, science, Earth observation, Earth science, all different things. And because they're becoming so sophisticated, they're generating so much data, and they do not have the capability, especially if it's a company with a CubeSat or small satellite, they don't have the capability to download this data. If you have 1 or 2 ground stations, you have maybe 4 times a day you can see your ground station, which gives you maybe an hour or 2 a day to download your information at a very low bit rate. So even for those satellites, our antenna system with a 1 gigabit per second for the CubeSat could give them the ability to download all these images and all this information in one pass or two passes, and not wait days to download the information and then provide it to the customer. So it's also a benefit for satellites that have other sensors and images on them. There's another application which is also LEO to GEO. So if you want to eliminate the need for a ground station, you could have our system on a satellite and look to a GEO satellite, and you can see a GEO satellite nearly all the time. And that way you can download your information nearly 22 hours a day, which gives you, online coverage, online ability to download your data and provide it to your customer.
Well, that's again a very important point you're making that I haven't really seen within the industry articulated as well as you have. Let me just say that. I have one more question. I'll just kind of ask you. I'm sure your technology is patented, right? You're the patent holder. So, where do you see kind of a military application? Maybe command and control. Are you kind of be in that space?
Communications, satellites are many times dual use.
Right.
So, all our products can be classified as completely unclassified commercial system. But communications on a satellite it could always be dual use. So, anyone can use it for any application. It depends on the application. So it depends on what pointing you need and what band you need. It can easily be also provided for Ministry of Defense of any country. But in the end, it's a communication. We connect a point to a point,
right?
And anyone can do whatever they want with it.
Okay, great. Well, my final question is: do you have any more information for our subscribers?
I think the important thing is that we finished our first development of the small size product. We're launching on the beginning of next year.
Do you have a concrete date on that one?
Not yet. We're first quarter of 18.
Okay.
When we have the final announcement of the launch, obviously we'll send that out. We'll be proving, the technology in space, and when we're showing that capacity of downloading and uploading 1 gigabit per second from a CubeSat. By the way, with a very small dish on the ground. It's not as if we're doing this with an enormous dish on the ground.
Well, it's still VSAT, right? It's still, but it's small.
It's 30 centimeters on the ground, which is small. Because anyone can have a link budget with a 10-meter antenna on the ground.
Sure.
But we're still doing it with a very small.
Yeah, that really definitely has a military application right there.
You said it.
Yeah.
So I think demonstration is our next interesting the company.
Well, Dennis, I want to thank you very much for your time. And
thank you.
I know you're a busy guy, and so again, thank you on behalf of our subscribers, GMC Stream. Thank you.
Thank you very much.
That was